Welcome back to part 2 in the series of making snake with Unity's Project Tiny. In the last video, we made the snake movement system and the screen wrapping system. In this video, we'll be making the snake's body, or the snake segments, or the snake's tail. So the first thing we're going to want to do is we need a way to store the snake tails onto the snake head so the snake head knows how many tails it has. Normally we would use something like an array, but in Unity Tiny we need to be a little more memory safe. So we're going to be using something called an iBuffer element data. And iBuffer element data store into what are called dynamic buffers. You can read more about them on the Unity documents, which I'll provide a link for in the description below. But I may make a video later down the road going more in depth on how iBuffer element data and dynamic buffers work. But I believe from following along with this video, you should understand them enough to be able to use them in your own projects. So let's make a folder to hold our buffers. We'll call it buffers. And inside of here, we're going to make a C# system called snake segment. It's not actually going to be a system. We'll change that when we open it up, but that's what the button says. After creating your script, remember to go to Assets, Open.C# Project so that your IDE will be able to recognize the script. Then we can go into here, and we can find the script we just created and open it up. And let's go ahead and put it inside of our snake namespace. And then instead of a class, it's going to be a struct. And instead of a component system, it's going to be an iBuffer element data. Then we can remove the protected override void. And inside of your iBuffer element data, we want to declare what the iBuffer element data is going to be. In our case, it's going to be an entity. And then we'll just call it a reference when we need to reference it. So this snake segment iBuffer element data allows us to create a dynamic buffer full of entities. And then with Unity Tiny, we can reinterpret them to other things. So now that we have our snake segment created, let's save and go back into our project. Then go to your snake head and click on Add Component and search for the snake segment that we just created. Now you can see you have a list on top of your entity inside of the component that we just created. So let's remove these. We'll be using this snake segment iBuffer element data to hold all the tails of our snake. So originally I was going to create the snake tail using the create entity system that Unity Tiny provides you, but at the time of recording this video, I was unable to assign a sprite to my Sprite 2D renderer through code. It could have been something I'm doing wrong, or it could be a bug in Unity Tiny. I'm not sure, but instead of doing that, we'll be using scenes to hold our snake tails. So let's create a new scene to hold our snake tail. You can right click in the scene folder, go to create, and create a scene. We'll call this the snake scene, or we'll call it tail scene. Then go ahead and open the tail scene up, and inside of here we're pretty much going to make the snake head. So if you want, you can just go ahead and duplicate the snake head, drag it into the tail scene, rename it to say snake tail, remove the snake head component, remove the snake segment component, and there you go. We'll now need to create another component for the snake tail as a tag to be able to recognize what entities are snake tails. So let's go into our components folder, create a new C# system and call it snake tail. After it's done compiling, remember to go to Assets, Open.C# Project. Then we can double click on the file to open it up inside of our IDE. Let's remember to put it inside of our namespace. Then change it to a struct. Change component system to say iComponent data. Get rid of the protected override. And since we're using scenes, we're going to need a way to tell if the entity has been loaded into the scene or not. So let's make a variable called public bool is created. And we'll use this to see if we've done our initiation code on this certain snake tail or not. Then we're also going to make another variable called number. What this variable is going to be for is for storing what position in the dynamic buffer array that this current snake tail is a part of. Now let's make a default state for this component to make sure it is created is set to false. Bools are usually always set to false initially, but let's do it just in case. So we'll say public static snaketail default. You're going to want to put it inside of your brackets. Then we'll say get var tail equals new snaketail, more brackets, and then we'll say is created is equal to false. Then we need to put our semicolon on the end of this bracket, and then we'll want to go here and say return tail. So this has set our is created bool to false, and if we wanted to automatically set it to true, we could change it to true. So now that we have our snaketail component created, let's go back inside of Unity3D and add the component to our snaketail entity. Now let's go into our snake movement system, and where our inputs are, let's create another input for spawning the snake tail just to test our code to make sure everything's working. Then after we confirm that everything's working, we can go back and refactor it to make the snake tail only grow when you pick up a piece of food. But since we don't have the food system in, let's create a simple way of growing our tail without needing food yet. So let's make it when you push the space key. And every time you push the space key, it's going to load in a new snaketail scene. And to do that, we're going to say scene service dot load scene async, and then we need to know the snaketail that we want to spawn. So let's create a way to find the snaketail. The way we're going to do it is with our game config file. We'll say public scene reference snaketail scene reference, just to make it cleaner. It'll make more sense what it is if it says snaketail scene reference. Now we can go into our snake movement system, and what we want to load is going to be world.tinyEnvironment.getConfig data. The config data that we want is game config. Then the data we want is the snaketail scene reference. Let's go back into Unity and set up the snaketail scene reference to our configuration file. So click on configuration, and then where it says snaketail scene reference, go to your scenes folder and drag in the tail scene that we created a minute ago. So when we push space, it should spawn in a snaketail. Let's move our snaketail over a little bit so that it'll be easier to tell when it gets spawned in. Save and unload your snaketail scene. Make sure if it says there are unsaved changes in the scene, do you want to save? Make sure you click on yes. And after unloading the scene, we can click on play, let the game build out, and we'll test if our spawning code is working. So click space, and you see we got a bunch of errors. And the reason is because we tried to load in our scene inside of a for each, but you're not allowed to do it inside of a for each. So what we'll do to fix that is if we go up to here where it says protected override void, right after the bracket, we'll make a bool and we'll call it should spawn, and we'll set it to false. So every time the on update reruns, it'll automatically set should spawn to false. Then we can take this variable, go down to here where our scene service is, we'll set should spawn to say true. Then we can just copy and cut the code we wrote a minute ago. Go down outside of your for each, say if should spawn, then paste the code that we just copied, and it'll only run if should spawn is set to true, and should spawn will automatically set back to false every time on update runs. So now we can go back into Unity after saving our script, wait for it to compile, then we can build the game out and test and see if that was the problem. After the game builds out, click space, and you'll see that our snaketail spawned in where we wanted it to. Cool. We can go ahead and start adding this to our dynamic buffer on our snakehead and get the snaketail to move along with our snakehead. So the first thing we'll do is add it to the dynamic buffer. To do that, we're going to go into our scripts folder and create a new script called initiate tail system. So init tail system. Click enter. After the game compiles, go to assets, open.c# project. Then we can double click on the script to open it up in our IDE. So inside of initiate tail system, what we're going to be doing is a for each loop over all of the snaketail entities. If the snaketail entity has not been created yet, we're going to find the dynamic buffer that we added to the snakehead. We'll take the entity reference of the snaketail and add it to that dynamic buffer, so we essentially have an array or a list of snaketails that we can perform code over to move our snaketail around behind our snakehead. So to do that, we're going to say entities.forEach, then we'll say entity with a lowercase e. And what we need to reference is the snaketail. So we'll find every entity that has a snaketail component. We'll call the snaketail component tail. Then we can type our lambda expression in an open and close bracket. Then inside of our for each loop, we'll say if tail.isCreated, return, saying if it already has been created, we don't want to run this initiation code on our tail. But if it has not been created yet, we'll want to first set isCreated to true because we are currently creating it. Then we're going to do a for each loop to look for the snake segment that we added to the snakehead. And because snake segments is an iBuffer element data, we're going to be using a for each loop using a dynamic buffer instead of just an entity like we did just now. So say entities.forEach dynamic buffer. The dynamic buffer that we're using is snake segment. We'll call our buffer segments. Then we can type our lambda expression in an open and closed bracket. And once we find our segments dynamic buffer, we can say segments.add new snake segment. And then inside of here, we can say reference is equal to entity, the entity being the entity that the snaketail component is on. Now, one other thing that we want to do is, if you remember, we also set up this number variable. So let's set the number to be the snaketail's position that it currently is within the dynamic buffer. So let's go back to our initiate tail system. Inside of here, we'll go above if tail.isCreated. We'll say var count is equal to 0. And then after we set the reference outside of the add, we'll say count is equal to segments.length. Then we can say outside of the for each loop, tail.number is equal to count. So let's run the game and see if the code that we just added causes any errors. When we push space, the snake tail is created and no errors show up in the console, so it must be working, maybe. Let's add the snake movement system code in for the tail part, and if the tail moves correctly, we should have confirmation that the dynamic buffer is working correctly. So to move the tail, after we say translation.value is equal to position, we're going to say move tail. So let's create this function called move tail. Say private void move tail, and inside of here we need to find the snake segment dynamic buffer that we created on the snakehead. So let's say entities.forEach, and one thing to keep in mind when using dynamic buffers and for eaches, you always have to look for your dynamic buffer before you look for the entity or any components on your entity. So say dynamic buffer. The buffer we want is snake segment. We'll call it segments again. And I just noticed we misspelled segment there, but we'll just leave it for now. You can fix it in your project. I'll go back and fix it later. Then we need to reference the snakehead. Do our lambda expression and open and closed bracket. Oh yeah, and also remember to name your snakehead component. We'll call it snake. After creating our for each loop, let's do a for loop over the segments. So we'll say for int I equals 0 if I is less than segments.length I++. And inside of this for loop, let's find our tail. So we'll say var tail is equal to entity manager dot get component data. The component data that we want is snake tail, and the entity that we want the component data off of is segments I dot reference. Then we can check if the tail number is equal to the same number as the segments.length by saying tail.number is equal to segments.length. If it is equal to it, that means this is the last tail in our tail dynamic buffer. So what we'll do is we'll move that snake tail from the end of the array to the beginning of the array, which will simulate the snake tail movement within our game. So we'll say var translation is equal to entity manager dot get component data. The component data that we want is the translation. The entity that we want the data off of is segments I dot reference. Then we need to move the snake tail to the position that the snake head was in before it moved last. If we go to our snake head component, we need to add a variable to store its last position before it was moved to its new position. So we'll say public float3 last position. And now we need to actually set the last position to the position that it should be at when the snake head moves. So going back into the snake movement system, right above where it says translation.value is equal to position, we'll say snake.lastPosition is equal to translation.value. Now we can use this last position variable on the snake head to put the snake tail in the position that the snake was at before it moved to its new location. So we'll say translation.value is equal to snake.lastPosition. Then we need to set the component data by saying entity manager dot set component data. The entity we want to set the component on is segments I dot reference. The component we want to set is translation. Now, since this was the last tail in the array, we'll want to set tail.number equal to 1 since we're moving it to the first tail in the array. And we'll also want to set the component data for the tail, so we can just copy this and change translation to say tail. Now, if it is not the last tail in the array, we'll want to say else tail.number plus or equal to 1 because it's being moved 1 back within the array. And then we can say entity manager dot set component data segments I dot reference and tail. Let's save this, go back into Unity, let it compile, and then we'll build the game out and see if it works. So click play. Then we'll move our snake head around, click space, and you'll see that it is working, but it's creating a bunch of tails at once. And the reason for this is, if we go back into our code, we can look where our input is, and we're using get key instead of get key down. So it's running for every frame that the game still registers we're holding the space key down. So we can change that to get key down. And another thing you might have noticed is when the snake tail initially loads, you can see it in the center of the screen. And the easiest way to do that is to load in your tail scene. Just take your snake tail and move it off the scene. Now unload your tail scene, making sure to click yes to save. Let's click on play, rebuild the game, and see if this is working. Let's move our snake head around. Click space, it grew one tail. Click space again, it grew another. And excellent, it's working perfect. Our snake wrapping is working good, and we have a fluid snake movement. Cool. So, I think this will be the end of this video. In the next video, we'll set up the food system to where your snake tail only actually grows when you collide with a piece of food. But we'll end this one here. I hope you have a wonderful day, and I hope you enjoyed this video. If you did, or you're looking forward to the next video, please consider liking and subscribing to the channel. Thank you, and have a wonderful day.